Section 4, the first part of the Section 4 of Chapter 7 is evaluating logarithms. And you might say, logo what? Here we go. So logarithms help us to solve exponents. All right. So let's look at this. We know that 2 squared is 4. And we know that 2 to the third power is 8. But 2 to what power is 6? So what we can do is this. A logarithm helps us to solve those exponents that aren't easily solvable. So b to the x power equals y. Backwards is the log base b of y equals x. Okay, so here's the deal. Once you get this, it's going to be, oh yeah, I got it now. But it's tricky. It's tricky. So write it down. Please write this down. Okay, thank you. So log base b of y equals x. So the parts and pieces in a log are like this. If you read it correctly, it'll help you to remember. So log base b is your base. So you can take this log base b of y and turn it into an exponent. B is your base, and x is the exponent. And b of x is y. All right, so you're going to need to write that down, and you're going to need to look at all the pieces and see where they come from until it clicks, until it makes sense, okay? So what we're going to do is this. We're going to take in these first few, what we're going to do is we're going to rewrite some logarithms and just rewrite them into exponential form. So what we've done here is this is already a logarithm that's solved, and so this says log base 2 of 32 is 5. So the base is 2, and the exponent is the answer. So the exponent is 5, and that's going to equal 32. And so then you can see 2 times 2 times 2 times 2 times 2 is 32. So far, so good. So let's do the next one. If you think you got it, kind of pause and skip ahead and make sure, and then come back to me and watch and see if you've got it, okay? So log base 10 of 1 is 0. So the base is 10. The exponent is 0. And 10 to the 0 power equals 1. And now this is something, let me put this in red. This is something, any log to the 1 power is always going to be 0. All right? Any log to 1 is 0. Any log with any base, any log to the log of 1 is going to be 0 every time. Okay? So the next one says log base 9. The exponent is 1, and anything to the 1 power is itself. So that's another one that you need to remember. If you've got the same base as the log that you're taking, your answer will always be 1. All right? Okay, and the last one says log base 1/5 of -2 equals 25. So you can see that the base, the small numbers, is the base. So there's our 2, our 10, our 9, our 1/5. And the answer to a logarithm is your exponent. So that's the 5, the 0, the 1, the -2. And so then this number becomes the number that you get when you take that base to the exponent. So that's how we're going to find this 2 to the what? Equals 6. All right, we can plug those in and find that. All right. Now let's take that same concept and let's evaluate. Let's come up with value, with numbers for it, okay? So if they don't give us the answer, how do we find the answer? Here's what we do. So log base 3, so there's the base is 3. We don't know the exponent, so that becomes x, and that equals 81. All right, so in this case, what we can do is, well, let's see. 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is 81, so it took 4 3s, it took multiplying 3 4 times to get our 81, so therefore the x is 4. Okay, so if the x is 4, then that's our answer to our log. Let's do another one. Log base 1/4 of 16 equals what? So we've got the base is 1/4. We don't know what the exponent is. That's what we want to find out. And we want it to equal 16. So we take 1/4 times itself. How many times to get 16? Well, I know that 4 times 4 is 16. But then it would be, if we had x as 2, that would be 1/4 times 1/4. That would be 1/16. So if you take that exponent and make it negative, that's going to flip this fraction and put it up in the numerator. So we actually want the x to be -2. Am I in your way? Okay, so because 1/4 to the -2 power is going to flip that fraction and make it 4/1, and then times 4/1 again would be 16, which is what we want. So our x is -2. Okay, are we getting there? Let's do a couple more. All right, log base 10. So our base is 10. We don't know the exponent, and we want that to equal 0.001. And now what we can do is you can either put it as the fraction or make sure that you recognize that's tenths, hundredths, thousandths. That's 1/1000th. So if we took x to the 3rd power, that's going to be 1,000. But we need to flip it to make it a fraction. So it's going to be to the -3 power. Okay, so by flipping it and making it the -3 power, this makes our 10 to the -3 power. We'll flip it and make it 1/1000th. Okay, so the log 64 of 8. So base 64. The 64 is our base. We don't know what the exponent is, and we want that to equal 8. So 64 to some power equals 8. Oh no. Okay, well, you know that 8 times 8 is 64, right? So if we take the square root of 64, that gets us back to 8. So what if we take the 1/2 power? Right? Because the 1/2 power is taking the square root. So 64 to the 1/2 power is the square root of 64, which is 8. Whew. You doing okay? Hang in there. Don't wrinkle your nose at me. You can do this. Okay, here we go. So now there are a couple of things that are going to be common. So there, what we've got is a couple of things with logarithms. A common log has base 10. So if I just say log of something without giving you the base down there, then that's going to be a base of 10. All right, and often we use that simply because our system is a base 10 system. All right. Also, we use the natural log. We use base e, which we just talked about in the last section. So we use base e a lot. If we use base e, then we're going to show it with an ln of x, all right? And so this simply means log of x, and this means natural log of x. And the cool thing is, with a lot of these, once you have them, and now that I've made you work through it and understand where the parts and pieces come from, there's a cute little button on your calculator. There's one that has log of x, and there's one that has natural log of x. You should go to your calculator right now and find those buttons. One is just going to say log of x, and one is going to say natural log, ln of x. All right? So when I give you a problem like this, and I say, evaluate log of 0.85. When I say evaluate this log, your calculator is going to do this for you. So go to your calculator, and the trick is going to be, you've got to put the numbers in first before you press log, all right? So first you'll put in 0.85, then press the log of x button, and you should get out, what should you get out? You should get out negative 0.071, and I have oh my goodness, my brain. These are rounded. Whew, rounded, that's the word I'm looking for. Okay, so then the same type of thing with the natural log. You have to put in the 22 first. Put in 22, hit the natural log button, and you should end up with 3.091. Go ahead and do it now and make sure that you get the same number that I get. And do that while I erase. And we're going to do a word problem and then be done. Oh, I would erase, but I lost my eraser. Check that out. I'll be doggone. Huh, can't erase. Well, I'll be. Oh my goodness, it's all the way across the room. How embarrassing. Okay, so got all this? Woo-wee! This, once again, these logs are going to be in equations, a lot of times in business equations. And so that's the type we're going to use right now is a business deal. Selling video games. Video game sales can be shown with this equation. And the cool thing is you don't have to come up with the equation. They're going to give you an equation. And in this case, they've indicated that this equation shows that Y is the monthly number of video games that are sold in the thousands. So they've made our lives easier by dividing this by 1,000 already. So the monthly number in thousands. And X is the number of months after a game is released. So once again, after something new is released, as soon as it's released, it's going to sell a lot. And then as time goes on, it's going to sell less and less. So they want to know, well, how many of these games can we expect to sell in the 10th month? And these numbers are really good for business models so that they know when to pull it and when to put in a new product and these types of things. So if you're interested in business, these types of exponential decay and growth are going to be helpful to you. Okay, so for right now, let's just put the numbers in. You've got an equation, you've got the numbers you need, so put them in. So in this case, Y is what we're trying to find, and we want 20 times the natural log of X, remember, is the number of months after a game is released, and we want to know the 10th month. So you're just going to put in 10 minus 1. 10 minus 1 is 9, plus 35. Now, the only trick is going to be remembering your please excuse my dear Aunt Sally. Make sure you do the order of operations correctly. And I can't use my calculator on my phone because I'm using my phone as a video camera. Go figure. All right, so I have done it already though. So what you'll do is this. You'll press 9. And then you'll press the natural log button. And now I hope you're doing this with me, okay? It does you no good if I just give you the answer and woo, there it is, I know how to do it, okay? So get your calculator and be doing it with me. So 9, then press the the natural log, take that answer, and you'll multiply by 20. Take that answer and add 35. Now, if you've got a graphing calculator or a scientific calculator, you can actually press in these buttons in this exact order, and your scientific calculator should do that order of operations for you. All right? But I think that most of you have just your handheld devices, and so you can use those for a calculator in this case. All right, so once you do that, you should end up with the number 78.94449 and other numbers. So what we want to know is how many video games did we sell in the 10th month? And if you'll remember, so did he sell 78 games? That's not very many. Don't forget to go back, and your Y indicates the monthly number in thousands. So you've got to multiply that by 1,000. So you move your decimal 3 places. And so 70, and what we're going to do is just kind of round. So 78,944, let's just round it to 79,000 games because you don't need to know exactly how many, and this is an estimation anyway. So you're going to sell, in the 10th month, you're going to sell roughly 79,000 games. All right, so here we go. Logarithms start getting a little bit more tricky, a little bit more cumbersome, but what you can do is just stop and slow down and look piece by piece by piece. Make sure that you remember where those parts come from in a log. This is going to be the most important part here, to know which part. The base comes from here, the exponent is your answer from your log. All right, so make sure you know where those pieces come from, even though on a lot of these problems you will be able to use your calculator. All right, see you soon.